Good afternoon. I know I'm supposed to start with a joke so to keep you awake, but I don't have any good jokes, so we'll just start with a lecture. Okay, my disclosures. So I'm going to try and convince you over the next 20 minutes that shortness in adulthood at a population level is a result of growth faltering in childhood. Whether or not we actually care about shortness in adulthood is something we might want to focus on in the discussion. So, shorter adult height is a result of deprivation in childhood. These are data from the cohorts collaboration that several of us in the audience have worked on. This is 6 birth cohorts from 5 different countries that have been followed. They are all now adults, so these are the adult data. I'd like to point out some obvious things, that women in these studies are shorter as adults than men, not surprising. That both men and women from the cohorts in the Philippines, in India, and Guatemala are substantially shorter than the cohorts from Brazil and South Africa. And that within any cohort, for men and for women, the adults who come from poorer households are shorter than the adults who come from less poor households. We've heard before about the early growth. I'm going to give you some more data now on growth. You're going to see more growth charts and more kind of rates of growth. It is also in the median child in the growth data has attained half of their adult height by age 2. What this means is because the rate of growth between conception and age 2 is greater than the rate of growth from age 2 to adulthood, that the potential for growth failure or growth faltering is greatest in early childhood. Growth rates are fastest in that period, and the energetic demands on growth are therefore greatest in this period. Children are young, they're dependent on their caregivers, and they have very small stomachs. Growth happens over time. It's a process. Height, which is what we measure at any one point in time, is simply the integral of growth velocity from conception, where we assume that it is 0, through age t. Growth has to be non-negative. And in order to measure growth, we need multiple measures of height. It is actually quite hard to measure length in young children. They squirm. So we have a problem of measurement error. We'll come back to that in a second. We've seen charts such as this before. I'm not going to dwell on it to save some of my own time. Right? Growth velocities in the red and the green are highest in early childhood. They decrease through to the adolescent growth spurt and eventually decline towards 0. When the growth velocity is 0, that is adult height. In the blue, we see the linear height of these at the same ages. We had a bit of a discussion this morning about growth standards. It is absolutely clear that if you take children from middle class and upper middle class families in multiple countries, in multiple areas, regions of the world, and you follow them prospectively. These are households where the mother doesn't smoke, where the household has clean water, where the household has electricity, where the child is breastfed, etc. These children grow along the same pattern. This is the average of the cohorts that were followed. They are indistinguishable from each other. From about age 6 months to about age 5 years, that same study took cross-sectional measurements. So this is one measurement for each child. This is not prospective data. There's a little more scatter here, but again, the growth patterns from age 6 months to age 5 years are superimposable on each other. There's no difference in growth in children who are not growth restrained. These are the averages. Of course, not all children grow along the average line. This is where genetics comes in, right? We heard this morning about 50% of child height can be explained by genetic variations from the GWAS studies. That means half is unexplained. But even those GWAS studies explaining half, that means there is variation. And the way we measure variation in normal children is we have the median, and then we have children who are above the line, and we have children who are below the line. We use the z-score to describe that. The z-score is the height of the child minus the median height of the reference child at that same age, divided by the standard deviation of height at that age, right? Z-scores in a population that is growing normally have an average of 0, and you have children who have positive numbers, and you have children who have negative numbers. Over time, children can grow along that line. They can falter. In other words, their z-score goes down. Or they might catch up or experience growth recovery. After a period of faltering, their growth might then increase compared to what it was previously. We saw a version of this chart this morning. Growth is not a continuous process. This is daily measurements of one child. Growth is a series of jumps. Linda talked this morning about the regulation of these jumps. Each jump is about 1 centimeter in length. More and larger completed jumps happen, and they result in faster growth velocity, which is the change in length over time. Missed jumps we experience and the child experiences as growth faltering. A child needs to be adequately nourished in order to be able to go through this jump. It is energetically intensive. Because of all that, most growth faltering occurs in the first 1,000 days. These are data from 54 low and middle income countries that collected in roughly 2000. This is the standard Victoria plot that every nutritionist has heard of multiple times. The dark blue line is the one that I'm going to focus on here. This is height for age. It drops precipitously from birth down to 24 months and is pretty stable after that. Weight for length, which I will come back to later in this presentation, is roughly at 0. And then the green, which is the weight for age, is intermediate because it is calculated based on the blue line and the red line. So it's got to be an average of those two. Growth faltering varies by region, and it is the overall pattern is there for every region in all low and middle income countries. Growth faltering is most severe in the Southeast Asia region in the green and the Africa region in the red. Andrew, you and I might want to talk later about why these children are short at age 2 and they're not shorted as adults. Right? That would be an interesting topic. Growth faltering in childhood is also related to household poverty. These are the same 6 birth cohorts. This is now length at age 2, not adult length. The height for age Z at age 2 patterns the pattern we saw in adult height. The children in the Philippines, India, and Guatemala are substantially shorter at age 2 than the children in Brazil and South Africa. And within each cohort, the children in the poorest households are shorter or have lower length for age z-scores than the children in the least poor households. Growth faltering is not inevitable. It's not something that you are born with. These are 9-year-old children in Guatemala. They're indigenous children. They were photographed in Guatemala. The line that you see there is the reference line for 9-year-olds. They are short. These children are indigenous Guatemalan children, but they were born in the United States and they live in the United States. They are not short. In fact, if you do surveys of Guatemalan children, the orange line is Mayan ethnic children living in Guatemala. The green line is a survey of Mayan children in the United States in 1992. The blue line is another survey of Mayan children in 2000. And the dashed line is the US reference child. Interestingly here, the blue line children were almost all born in the United States. The green line, about half of them were born in the United States. So Mayan children in Guatemala are short, but it is not inevitable. It is not something that cannot be changed. More data from Guatemala. This is a study that I believe Sarah talked about the villages that these children come from. We've been following these villages since the 1960s. The red line is the length for age Z of these children in the mid-1960s. The green line is the height for age Z of children in the same villages, obviously not the same children, in 2007. There has been an increase of 2 standard deviations, 2 height for age Z scores over that period. Children have gone from an average height for age Z of -3 to an average height for age Z of -1. At the same time, we have seen generational increases in adult height. The women born in the 1970s, that's the red line. As adults, they're 3 centimeters taller than their mothers were in the 1970s. This pattern has happened globally as well. Globally, there is less growth faltering than there used to be. These are data from Cesar Victoria's work comparing data from 2000 and 2015. These are country-level averages. Right? The solid line is low-income countries. The dashed lines are middle-income countries. The red is the older data. The blue is the newer data. So growth faltering still seems to be occurring if you compare the blue to the red. The degree of faltering is less than it was 15 years ago, so all children on average are taller. The poorest in each of the low-income countries and the middle-income countries experience the most growth faltering. The solid lines, which is again, the low-income countries, and the middle-income countries are the dashed, right? The blue are the poorest in those countries at a household level, and the red are the least poor in those household levels. There's a lot of overlap then between poor households in middle-income countries and least poor households in the poorest countries. So I haven't used the word stunting until now. I'd like to just go over that quickly. Stunting is having a Z-score of -2 or lower, right? In a population that is growing according to the standard, 2.5% of the population will be stunted. If there is overall growth faltering and the mean is now less than 0, the population, the prevalence of stunting will go up. However, in that population, everybody just about has experienced some growth faltering, but not everybody is stunted. So stunting is a reasonable tool for comparing populations. It is not a useful tool for individual diagnosis of a child. You need to know what the child's potential is before you can make a determination about whether or not the child is stunted. Just to give you an example of that, these are the same data from our villages in Guatemala, where the prevalence of stunting has gone down from 73% in 1968 to 23.1% in 2007. That number is still substantially higher than the 2.5% that a well-nourished population will experience. Global stunting has gone down globally from about 32% to about 22%, and that has happened in every region that UNICEF monitors. I'd like to switch now and talk a little bit about underweight and overweight. I'd like to come back to this figure, which we've already seen, where weight for length is roughly at about 0. Well, an average hides things, right? It can hide elevated levels of both overweight and underweight, yielding an average of 0. Weight for height differs dramatically between low and middle income countries. The dashed lines here are the middle income countries. The solid lines are the low income countries. Again, these are data from 2000 and 2015. There's been little change within each population, right? But there is this one standard deviation difference between low income and high income weight for heights. So global overweight, right, has increased. This is a problem that's been recognized by UNICEF. The global prevalence has increased from about 5% to about 6%. Not a huge increase over time, but it's in the wrong direction. And this is true in almost every region, UNICEF region. Low weight for height, thinness or wasting at the extreme level, right, is concentrated among the poorest. It's concentrated in the low-income countries, and it is concentrated in the the poorest households within those countries. Right? So, to conclude, this very rapid survey. Mean fight for age in low and middle income countries has continued to increase in all regions around the world. That's a good thing. There are still major differences in height by socioeconomic level. That gives us an area for work within those countries. That's true both within countries and across countries. In the middle income country bracket, high weight for height, in other words, child overweight, is a concern. In low-income countries, low weight for height or child underweight remains a public health concern, especially among the poorest. So we have a public health challenge to continue to make increases in height for age Z while preventing child overweight. That is the challenge that we as nutritionists have. Thank you.